Good day everyone. Today we're going to discuss all about the physical properties of soil. In this topic, we're going to discuss all about the concepts and the derivations of the formulas regarding the physical properties of soil being used in soil mechanics calculations. This topic is very essential as this will be the foundation of our succeeding discussions in this subject. To start with our lecture, let us first recall what is the density and unit weight of water. The density and unit weight of water is equal to 1000 kg per cubic meter or 9.81 kilonewton per cubic meter. Also, we need to recall the basic formulas we used in physics subject. We all know that the unit weight of water is equal to the weight of water all over the volume of water. And from that formula, we can derive the weight of water is equal to the unit weight of water multiplied by the volume of water. Also, the specific gravity of any substance is equal to the unit weight of that substance all over the unit weight of water. And it is also equal to the density of substance all over the density of water. The unit weight of any substance from that formula can be derived and it will be equal to the specific gravity of any substance multiplied by the unit weight of water. Also, we can derive the weight of substance is equal to the unit weight of substance multiplied by the volume of substance. It will also be equal to the specific gravity of the substance multiplied by the unit weight of water because we substituted the unit weight of substance here multiplied by the volume of substance. We're going to discuss all about the weight-volume relationship of soil first. First, this is a microscopic view of the soil. So if we're going to look at the soil, it is composed of solid. So these are soil solids or soil particles, and the white spaces here are what we call void spaces, which can be occupied by water or air. So, soil is the only thing in this world that has three phases of matter in it. We have solid, which is the soil particles, the liquid, which is the water, and the gas, which is the air. It can also be a two-phase system, wherein it can be dry, walang tubig. So, it can only be just soil particles and just air. So, it can be two-phase system, or these void spaces can be completely saturated by water and it will be just a two-phase system, just soil particles and water, so it will be completely saturated soil. But soil can never be a one-phase system. It can't be just soil particles, or it can just be water, or it can just be air. So it will always be a three-phase system or a two-phase system. Laging may combination. So if we're going to separate these particles or this microscopic picture of soil, ganito siya makikita. This will be the soil particles, this will be the water, and this will be the air. So the total volume of this soil is equal to the volume of soil solids plus the volume of voids. So we know that the volume of voids can either be occupied by water or air, or both. So that's why volume of voids is equal to volume of water plus volume of air. When it's completely saturated, volume of voids will only be equal to the volume of water. Or if it's completely dry, the volume of voids will only be equal to the volume of air. Next, the total volume will be equal to the volume of soil solids plus the volume of water plus the volume of air. So if it's completely saturated, the total volume will only be equal to the volume of soil solids plus volume of water. Or if it's completely dry, the total volume will only be equal to the volume of soil solids plus the volume of air. Class, the soil will always have void spaces. Next, we're going to tackle about the weight of soil. So the weight of soil is equal to the weight of soil solids plus weight of water. Why is that? There is no weight of air in here because we all know that the weight of air is zero. So moving on, we tackle about the void ratio. Void ratio is defined as the ratio of volume of voids to the volume of soil solids. That's why it's equal to VV over Vs. Note that void ratio can range from 0 to infinity. Why? Because volume of voids can be more than the volume of soil solids, but it is very rare. So void ratio can be expressed in percent. Next property of soil is what we call the porosity. Porosity is defined as the ratio of the volume of voids to the total volume. It's written as VV over V. So it is also expressed in percent and can range from just 0 to 1. Why? Because volume of voids can never be more than the total volume because volume of voids is just part of the total volume of soil. That's why it just ranges from 0 to 1. Next is the relationship between void ratio and porosity. And we know that void ratio is equal to VV over Vs. If we're going to write Vs here, it's also equal to the total volume of soil minus the volume of voids. And we know that N is equal to VV over V, and VV therefore is equal to NV. If we substitute that in the formula, so VV here will be NV and VV here will be also NV. So then this will be equal to NV over V quantity 1 minus 1. If we cancel V here, it will be equal to N over 1 minus N. Also, we need to recall that N is equal to VV over V. In that, E is equal to VV over Vs. That's why VV here is equal to EVS. If we substitute that in the formula of porosity, VV will be EVS and the total volume is equal to volume of voids plus volume of soil solids. So again, substitute VV here. So this substitute the EVS here, and this will be equal to EVS plus over EVS plus VS. And EVS all over Vs quantity of 1 plus E. If we cancel Vs, it will be equal to E over 1 plus E. And that is the relationship between void ratio and porosity. Next property of soil is what we call the degree of saturation. So the degree of saturation is defined as the ratio of the volume of water to the volume of voids and is equal to VW over VV. Note, degree of saturation varies from S is equal to 0 for completely dry soil and S is equal to 100% for totally saturated soil. So if it's completely dry, volume of water will be 0, so 0 over volume of voids will be 0. That's why if it's completely dry soil, S is equal to 0. And if it's completely saturated, so volume of voids will also be equal to the volume of water because, again, the volume of voids is totally occupied by the water. That's why the volume of voids will be equal to volume of water and S will be equal to 100%. Next, we have the moisture content. Moisture content is also referred to as water content and is defined as the ratio of the soil weight of water to the weight of solids in a given volume of soil. Or this will be omega or MC. So I prefer MC to be used rather than omega. And it's equal to weight of water W over weight of soil solids. Note that moisture content can vary from 0 to infinity. Again, why? Because weight of water can be more than the weight of soil, but it is very rare situation. Next, the relationship of the degree of saturation, void ratio, moisture content, and specific gravity of soil. So we all know that weight of substance is equal to specific gravity of that substance multiplied by the unit weight of water multiplied by the volume of substance. So we recall this formula already. And then the weight of soil is equal to specific gravity of soil multiplied by the unit weight of water multiplied by the volume of soil. If we assume that the volume of soil solids is equal to 1, the weight of soil solids will be the specific gravity multiplied by the unit weight of water only. And then, we know that the moisture content is weight of water over weight of soil solids. Therefore, weight of water will be equal to moisture content times weight of soil solids. And weight of water is equal to NC multiplied by specific gravity of soil multiplied by unit weight of water because we substituted the value of weight of soil solids here. And then unit weight of water is equal to weight of water over volume of water. And therefore, volume of water will be equal to the weight of water over the unit weight of water by transposition method. So therefore, volume of water is equal to MC multiplied by specific gravity multiplied by unit weight of water. We just substituted the value of weight of water over the unit weight of water. And therefore, if we cancel the unit weight of water, we're going to get the volume of water is equal to moisture content times the specific gravity of the soil. And then, we tackle about the degree of saturation. Degree of saturation, as we recall, is equal to volume of water over the total volume of voids. If we substitute again the volume of water here, from here, it will be equal to moisture content multiplied by the specific gravity. And if we know that E is equal to VV over Vs, again, if Vs is 1, E will be equal to the total volume of voids. So this will be 1. So E will be equal to VV. If we substitute E here, we get S equals MC GS over E. And therefore, we get the relationship of degree of saturation, void ratio, moisture content, and specific gravity of soil as SE is equal to GS MC, or sometimes it just can be written by SE equal as SE equals GMC. So this formula is very needed in soil mechanics, this relationship. Next, we tackle about the unit weight of soil. So the unit weight can also be called bulk unit weight, is the weight of soil per unit volume, and that's why it's so equal to weight over volume. The unit weight can also be expressed in terms of weight of soil solids, the moisture content, and the total volume, and can be termed as moist unit weight or in situ unit weight. So if we derive the unit weight of soil, it's equal to weight over volume. And we all know that the total weight of soil is equal to the weight of soil solids plus weight of water all over V. So if we substitute that, this will be equal to, pag nilabas natin yung WS, this will be WS multiplied by 1 plus WW over WS all over V. And then, this one is WS over E. Ibig sabihin, weight ng soil solids over V, dry siya. So, therefore, we get the relationship that unit weight of soil or the moist unit weight of soil or in situ unit weight of soil or bulk unit weight of soil or also field unit weight of soil is equal to dry unit weight because this is dry, soil solids lang to, multiplied by 1 plus this is WW over WS is equal to the moisture content. So this is the first formula for unit weight. It's equal to unit weight, dry unit weight rather, multiplied by 1 plus the moisture content of soil. Next, we tackle about the moist unit weight, dry unit weight, and saturated unit weight. Again, the unit weight of soil is equal to weight over volume. And again, it's equal to, this weight here is equal to WS plus weight of water. If we substitute WW is equal to MCWS from the formula of the moisture content, which is equal to WW over WS. And then, the total volume of soil, as we all know, is VV plus VS. And therefore, pag nilabas natin yung WS, this will be equal to WS times 1 plus MC all over EVS plus VS. Why is this that it's equal to EVS? Because from the formula of the void ratio, it's equal to VV over VS. And therefore, VV is equal to EVS. That's why this will be equal to WS times 1 plus MC over VS times 1 plus MC. This WS over VS is the unit weight of the soil solids natin. That's why, and then multiply it by 1 plus MC over 1 plus E. We know that the unit weight of any substance is equal to GS times unit weight of water. The unit weight of soil is equal to GS times unit weight of water, multiplied by 1 plus MC over 1 plus E. So, if we distribute GS here, this will be GS plus GS MC over 1 plus E times unit weight of water. Or sometimes or most of the time, disregard na yung S because we know that this is the specific gravity of the soil naman. So G plus GMC over 1 plus E times unit weight of water is already acceptable. And then, we already derived the relationship between GMC and SE in our previous slides. So, diba, GMC is equal to SE. That's why the unit weight of water can also, unit weight of soil can also be equal to GS plus GMC is equal to SE. That's why SE is here all over 1 plus E times unit weight of water. So, if it's completely dry, there is no moisture content. This will be zero. This will be zero. That's why we cancel this. This will be zero. That's why the unit weight of soil in dry condition, or the dry unit weight, is just equal to GS over 1 plus E times unit weight of water. Or if it's completely saturated, we know that S is equal to 1. That's why if we substitute S equals 1 here, the saturated unit weight of soil will just be equal to specific gravity plus E all over 1 plus E times unit weight of water. Buoyant or submerged unit weight is equal to the saturated unit weight of soil minus unit weight of water. So if we substitute the formula of the saturated unit weight of soil, this will be equal to GS plus E multiplied by unit weight of water all over 1 plus E minus unit weight of water. Therefore, if we expand, this will be equal to this will be GS times unit weight of water plus E unit weight of water minus unit weight of water minus E unit weight of water all over 1 plus E. And this will be cancelled. That's why GS minus 1, because this will be just GS unit weight of water minus unit weight of water all over 1 plus E. So, nilabas natin yung unit weight of water. That's why this will be equal to GS minus 1 multiplied by unit weight of water all over 1 plus E. And then, in terms of density, palitan lang natin yung unit weight natin ng unit weight of water. Gawin lang natin siyang density. So, that's why the density of soil is equal to G plus G density of water multiplied by 1 plus moisture content all over 1 plus E, or pag sinulat natin siya, this will be equal to G plus G omega or GMC over 1 plus E multiplied by density of water. And then if it's dry density, the unit weight of water will just be equal to the density of water. So it's equal to specific gravity of soil multiplied by density of water all over 1 plus E. And if it's saturated, GS plus E multiplied by density of water over 1 plus E. And then if it's, that's buoyant. This is buoyant. Buoyant density is equal to GS minus 1 all over 1 plus E multiplied by density of water. So there are also other useful formulas in soil mechanics. These are the zero air void unit weight. It's equal to GS multiplied by unit weight of water over 1 plus GMC or G omega. Air void ratio is equal to N times 1 minus S, or degree of saturation. This is porosity. Air void ratio is also equal to E minus specific gravity of soil multiplied by moisture content over 1 plus E. And then we can also have the mass specific gravity or specific gravity of mass. It's equal to the unit weight or the moist unit weight of soil all over unit weight of water, or if it's density of soil over the density of water. And then the last formula for the physical properties of soil is what we call the relative density. So from the derivations from our lecture, the relative density